Namaste. Welcome to Androidiots podcast. I am Anupam Singh.
I am Tushar Gupta. We talk about what's new in Android, best practices, and how to be a better Android developer.
What we understood till now is what happens when you open your phone and there's a loader and there's a hell lot of thing that goes behind that.
Yeah.
And another problem you mentioned was there's a problem called as limit on dexing, and we can solve that through multi-dexing.
Yeah, so I think one point that we missed earlier was the dot class files use a 8-bit instruction file format.
Okay.
So that means whatever references that are being indexed, be it the literals, the type modifiers, the attributes, the methods, those are based on an 8-bit indexing table.
Mm-hmm.
So that means 2 to the power of 8 indexes max in one dot class file.
So you mean there's also a limit on in the class file itself?
Yeah,
How many
yeah.
methods I can have in the class file?
Yeah. So that's also another topic in itself.
Okay.
Like how what all things go beyond, like if you reach the 8-bit in dot class files.
Okay.
So is that the reason that Android doesn't compile directly
No.
.dex and
No,
go
so-
through a process of from
No,
dot
so-
class to class .dex, then classes .dex? Why not ship directly to
So
dex
because
files?
it's actually based on the VM architecture. So DVM doesn't understand dot class files because it introduced some new formats, right? Because DVM wanted a lot of class files, a lot of source code to be compiled in one class file, so that the lookup cost, not the lookup cost, the first time compilation cost
Is very less.
is lower. Yeah.
Okay.
So that you could actually be faster when you are actually running the application.
Mm-hmm.
So that is why the dex file came into existence, because now it holds a lot of class files into one dex file.
Mm-hmm.
So this dex file is based on a 16-bit architecture instruction file format. So that is why whenever we talk about the 64K limit, it is actually the 2 to the power of 16 indexes limit.
Okay.
That comes down to 65,536. And we call it 64K for the difference between 1000 and 1024.
Uh-huh.
So the bit differences. Anyways. So yeah, Manjit, you
So
are
what
doing
else?
something.
So yes, you are going like coding, making methods.
Making your code into clean architecture. So design patterns also cost you a lot actually, because you have a lot of methods. Whenever you introduce a layer or introduce some point of abstraction, some interfaces, some abstract classes, you are actually making the method count increase. And whenever you add libraries like the support library, for example, the support library in itself, the V7 version in itself has a method count of 12K. Out of the 64K, the 12K goes to the support library.
So they should reduce the limit. They say upfront, we are going to use support library. This is what you have.
So in Google I/O 2018, we all saw that the V9 library version would be released soon. So in which they actually catered to all issues like that. Suppose they had some components in V7, they had some components in V13, they had some components in V4, and V13 was made over V4. So if you include any component from V13, it would actually install the V4 library also. So there were a lot of issues with these libraries. So that's why in Gradle, we could actually exclude the modules of individual libraries, or we could actually extract the individual modules that we need. For example, whenever you write Android support library module card view, or or a cycler view, so that means that you're not actually downloading the whole library. You are just you just want this specific module.
Okay.
Yeah.
So that will save a lot of
So,
clicks.
yeah.
That account for me.
Yeah. So that is what should be done. In whichever case your source code is quite heavy.
But still, that compilation line has to be you have to thought before compiling,
Yeah.
because that can increase your limit. And if you are raising your limit, you should be enabling the multi-dex, which should be enabled if you are crossing that 64K. And coming to the point that how would you know that you are crossing that 64K limit?
Yeah.
So when you are making apps, compiling them and all, so there will be a point when the compilation
Will fail.
That's it.
and will tell you this method is not.
The first error that comes while multidexing is, I think, multidex not enabled. I don't remember the exact syntax.
It's something like that. Yes.
It's something like that. So that basically tells you that you have reached a method count which couldn't accumulate in one single text file. So you will have to enable the multidexing
And
compilation.
you also
part.
have to extend multi-dex application as far as I remember.
Yeah, we'll come to that. So now let's first, like, something that I would like to point out here is the DX toolchain actually supports more than 16-bit indexing also. You could actually say, like, I want 20-bit indexes, so you could actually have a more method count in a single text file. But now the issue here is our VMs are not very comfortable with the other file formats. So there had to be a standard, right?
Yeah.
So that each VM could actually know, like, the protocols of actually compiling the application. So that's why this standard was made as 16-bit, and so you could actually make it into a 18-bit file architecture or file format or a 20-bit file format, but that won't actually run properly in DVM or R.
So other layers basically have those 16-bit architecture fixed.
So
changing the architecture, the instruction format to 20 or 24 won't have any advantage.
Yeah, any advantage. It might even crash the application. So it would mostly crash the application in only some cases it would.
That's all we do.
Yeah.
We crash the application and fix it.
So
Yeah, man.
So now is the time you were enabling the multi-dex. You go into your build.gradle, you like set the flag to true.
Yeah.
And you compile that support library also.
Yeah.
You are using that limit also. So now.
So actually, there's this thought actually, which goes like, why couldn't the Gradle, automatically convert, the compilation to multi-dex? Yeah, because it's so simple. Like, your method count exceeded the limit, and now it would actually shift to the multi-dex. So it doesn't do this because multi-dex compilation is different whenever you don't have a multi-dex compilation. So suppose you have a method count of 75k, okay, so now your 65k methods would go in the main dex, okay, because that's necessary, etc, etc. Now comes the point where you'll have to, cater to another dex file or multiple dex files. So what's the algorithm here? Like, how it should be done so that, it's performance efficient, because as we discussed earlier that Art, actually, compiles only the main classes.dex file. It would compile the secondary text files only when it's needed. So that's why we have like a lot of ANRs with the dex switching, because whenever it needs to switch the dex file, your application might go into an ANR state. It might not. It might.
Yeah.
So this is happening because only the main dex file, the primary dex file, is getting compiled in the first stage. Okay. So the secondary text files needs to be arranged so well so that the lookup cost in each file isn't large. So suppose the 75k method count in this case scenario, you are left with 10k methods. So when you store all of these in the single text file, the lookup cost might increase depending on your app's use case, or or whenever your feature set is coming, which would actually, or how many features are coming, or how many instructions are running, like how fast basically. A 10k method count, a 10k method reference in a single text file might increase the lookup cost. That's why there are a lot of different algorithms which depend on the different SDK versions also. So if suppose you'll check your platform tools, the SDK tools in the libs folder, you'll find the DX command, the DX toolchain basically that we call out. So in that DX, so suppose you have like 4 SDKs downloaded, like 26, 25, 24, 23, and you will have a DX command in each of those. But the DX commands algorithm would differ from SDK to SDK because for obvious reasons, that we'll talk about. So what happens here is, so the DX command handles for this SDK version how the multidexing should be done. That is why there's no default multidexing enabled. That is why you have to explicitly say that since I am compiling an SDK version here, I am actually enabling the multidex, so that it will understand, it will check all the feature set, like what all classes are coming down in one batch. It will perform chunking on the method counts and have its own place, like these method counts could be accessed in a single flow or sooner, and there's a delay here. And around that logic, it builds up the multi-text files. So this was needed.
So if I understand correctly, if you have 75k method count, so the first 65 will go into the primary text files.
Correct.
The rest of the 10 will depend on many
factors
variables,
as such, that we discussed.
So these variables might be the feature set. Some of the feature set might have, suppose 2k of the methods are needed in one particular flow.
Correct.
So they will be loaded in one single text files.
Correct.
And then all of the other will be loaded in some other text files depending on the SDK versions or the features basically.
Yeah.
Okay.
So that's cool. Multidexing works perfectly. Aren't there any problems with multidexing?
So there are a lot of issues faced by multidexing. I mean, whenever you face multidex, the best advice I could give you is, lower down your protocols.
Don't go into multidexing.
Don't go into multidexing.
Like
it's a pit.
It's very easy to compile library, I know, and enable the flags. But yes, it increases the
It's
overhead.
the evil behind the black magic that we are talking about. The necessary evil, actually.
So there are some crashes that we are going to face when we are enabling the multidex flag. One of them is class not found exception and class def exception.
So for example, you have class def not found exception, which basically says that the class which was needed to run your application isn't present in the main text file, which the support library is released, but it does a decent job, but it doesn't actually resolve the indirect dependencies that go along the application class as well. For example, when you think of it from a basic level, whenever your application needs to start, since the main text file is the only text file which is being compiled in the first stage, classes that are needed for your app startup must be present in the primary text file, or else it won't know actually how to start the application.
Yes.
Now this is a very simple problem in when you talk about it, but when you dive deep down, it becomes a massive problem, because a lot of different applications have a lot of different dependency graphs. For example, some of your application classes, some of the apps would have application classes which have their ORMs or some databases initialized. Some would have image intensive tasks, so they would have image libraries initialized. Some would have something different. So now each of these libraries would be dependent on some of their internal dependencies. So this is what we call an indirect dependency.
So every basically application will have the different tree structure.
Yeah, a different dependency graph, or what we call it a dependency graph. So
yes, sir.
Now, not only your application class needs to be there in the main text file, the whole dependency structure should be present. Because if even a single file is not there, it would crash. Yeah. Because it won't be able to run the code. So this is how the problem becomes massive and depends on use case to use case. So for this, Google had its support library, multidex support library that we all know of, available to the developer community. And what it basically does is, before compiling, it would actually list down the application class as well as the direct and indirect dependencies to a certain extent to the base class loader of the Dex class loader, so that it would ensure that these classes would actually go in the main text file. So now this has your own issues, like for example, if you are using code obfuscation. Now in some of the Gradle build tool versions, for the newer version, the code obfuscation also happens parallelly. Okay? If there's a stage in where half of the code is obfuscated, and half of the method that go inside are going after the obfuscation. So that also creates an issue. Usually this won't happen, but this happens in various race conditions that Gradle faces. So this is con of Gradle, not the build process. Okay, so the multidex support library ensures to a good extent your main classes should actually go to the main text file. But again, there are
and the problem not stops here. This resolving nature of multidex library is dynamic. In some phones you have some dependencies which are resolved and the application runs well.
And that's a nightmare.
And one day that will goes and crash, and the class def exception or the class not found exception is going to be there. If it can't be able to resolve that dependencies, and that happens in runtime. So basically, it will also increase the loading of that application.
Yeah.
And so the application will crash in multiple cases. Can we avoid this crash somehow? One way is use Google multidexing library.
Yeah.
So we can also have a multidex.keep file.
Okay.
So what it does is that if you mention some path of a file, that you want to keep in main dex.
Which I would like to add here is a tedious process in itself. Like you would actually go to your for example your application class or your image libraries, some classes that are needed, the import dependencies. You would add your application class package name, your apps package name. You would add their whole package path, the canonical path basically, and it would go on. So it's like a tedious process whenever you have a good source code and basically you have like 100 text files that needs to go in the memory and 100 class files that needs to be
and it's an entirely manual process.
It's an entirely manual process. Plus, it's not guaranteed that this would actually ensure that these all classes would actually go in the text file. And it would be to a certain extent, but for example, your DX utility decides that okay, these are the main files that should go here, but I have this set also that is also on a priority basis. So DX has its own priority based mechanism. Okay. Now what happens is there will be a conflict if the 65k limit is about to reach. So some of the classes might not end up in the primary text file. We have a lot of different tool sets which developers have come through down the line, evolved through, like, which could actually parse the text file. Or now Android Studio's analyzer has came into picture, which would actually analyze the APK. You could actually go into each of the text files and manually check whether this file is present or not. That is again a tedious process. If you have like 100 classes, like who's gonna do that? Come on, like a developer has a lot of things to do, to focus elsewhere.
This is method is hit and try. Like you are thinking that this dependency has not been entered in your classes.dex primary dex. So you entered this in multidex.keep file, and this is like a hit and trial method. You are not guaranteed like this will be entering in this primary dex.
You would have like it mostly it will go, but how would I validate it? Like,
is there any way we can be sure?
How have you solved this problems?
Yeah, so we faced this issue with our product. So our method count is more than 1 lakh.
So we have huge.
Yeah, we have a huge feature set, a huge base. Okay, so we were facing these issues like on a regular basis. On some devices, something would crash. On some builds would crash. On some builds won't. So there was a lot of issues. Though we had our own CI setup, but even that wouldn't guarantee it. That's why we came up with our own module, our own library. We named it as Dexter. The name justifies itself. To actually have these tedious tasks, not be an issue actually. Like, be it simple, be it easy, and be it reliable. You could, with Dexter, you could actually ensure the classes which needs to go in the multi-text file with a simple annotation. There are a lot of variation with that annotation. So that annotation is a simple primary text annotation. So basically you would actually add an annotation at the primary text over any class file or Java file which you would like to have in the main text file, or any library file for that matter. But there will be some transitive dependencies that unable to decompile, or it would have to be decompiled first before you could actually edit them. So we have a support for extras also. So you could actually, in that same annotation itself, you could actually just generate specify the class path basically inside the extras field in that same annotation, and it would actually take care of it. These files also.
So you mentioned that the DX tool has its own priority list of putting the classes in the primary text file.
Yeah.
So how do you inform DX that this is my class which has to go?
Yeah. So DX has a switch named as main index switch. Okay. The DX toolchain has a switch in which you could actually specify a list of files the DX would actually ensure to go in the primary text. This is what the multitext.keep syntax does.
Okay.
Yeah. So behind the scenes, both of these work the same way. In one scenario, you have a lot of manual labor, and in the second, you have just a simple annotation to work up with. And then it doesn't stop here.
And there is also a Gradle plugin where you can validate that what goes inside your primary dex, classes.dex. So that it is basically a task. If you run that task, there will be like list of classes listed in the terminal, or you have also in the file which is dumped in your path, and you will be able to validate if it crashes, that you will be able to validate it.
What is the primary text?
Yeah, so in the first release we have like the task is there and you could actually list down all the classes. The second release that we are coming up, which would be available soon, in that this process would also be automated. Like you just enter the annotation or the classes, you will just list them down, and then after that you could actually enable a strict mode. That is what we are calling it. So in the strict mode, after your build runs, the validation task will also run by itself.
Okay.
And then it will again check and it will tell you the diff if there is any, and it will fail the build if it doesn't, if it sees an error or it sees any discrepancy.
So we are going to include this task in the Gradle tasks in itself.
In the
so
Gradle build lifecycle itself.
Gradle build lifecycle itself. So when you are going to build your application, this is going to run. That keeps you into a safe mode because you are not going to face any crash in runtime.
Yeah.
Okay. All things are solved in compile time.
So in short, you're doing God's work.
Well, whatever works. There's a problem.
So
we all are here to solve it.
So is Google trying to solve any of these problems, or
you're
not aware of it yet?
So I don't know. Like Google just gave their own multi-text support library and they said, yeah, that's it.
That's
Okay.
There hasn't been another update from them. The multi-text support library, I think it's currently running on a version of like 1.0.1 or 1.1.
3.3, I guess.
1.0.3, yeah. I think like a year back it was 1.0.1, so only two releases after that. So like.
So this Dexter, your library Dexter seems like a very important.
Yeah. So though currently Dexter also uses multi-text.support library because we haven't made our algo production ready to actually parse the dependency graph and capture all the classes and do that. That is for another release, a new version. So that would actually make the Dexter sole point for the multi-text issues in itself. So you won't need multi-text support library. You won't need anything.
So right now Dexter is built on top of multi-text support which Google has provided.
Yeah.
Yes.
But you're going to make it self-sufficient. You not have to use the.
Correct. Okay, so Amanjit, you would like to add something here?
So yes, while making that Gradle task, we have actually parsed that text file, which is made in your .apk file. We have written our own parser that is made on a random access file concept. That is basically reading the files according to the file format which the Dex has. We first verify that is it a Dex file or not. We then goes to a next stage. We have the string IDs. Then we have a class list which we are going to dump in a file, and then from there you can validate that your class is present or not. And we have a later vision also of methods, I think.
Yeah. So one more thing that we thought of, and we thought this is necessary, and this also would be mostly out in the next release. So this is basically the method indexing. So right now, everything works with a class-based model. So you could actually, ensure the methods of all of the methods of this class should actually go in the index. So this is because the DX toolchain is made that way. So we are working on some, pro hacks here so that we could actually work with the method indexing itself, directly method indexing. So, you won't actually need to specify this whole class should end up being in the multi-text, or you could actually specify 5 of these methods should end up in the main text.
But does it mean that those methods have to be pure functions? Because otherwise methods are generally related to the class, right?
Yeah. So whatever, in the bottom line, whenever your Dex stores it, whenever your Dex stores the method, it's it has its own method package format in which the data has the class ID, the type identifier, etc. So that is taken care of in the bottom layer. Though the DX toolchain doesn't give us a direct solution in which you could actually specify a method. So we are working on that, and let's hope we'll have something out for
and
method indexing.
Have you faced any problem with Kotlin? As in, has Kotlin given you any trouble in terms of text?
Okay, so I am not using Kotlin right now in my professional project as well. In some personal projects I have used them, but I haven't faced any issues to that through dexing. Basically, there's no. The issues are common across the Java because it's the same class file.
Yeah.
So the dexing journey starts after the class files, right? So
there's no difference.
Yeah. So because Kotlin is based on the same JVM architecture, so the compiler, the Kotlin C compiler, I mean that command of the compiler is also based on the similar instruction set. So it generates these class files on a similar format. So the issues you face in the Java class files
are the same
issues.
But yes, going down the range, if you have like a for loop, say like in Java you have a for loop.
Yeah, in the bytecode level it differs. So I would like to add something here, like it's not related to dexing, but it's related to any utility method that we use. Like we like to save the boilerplate code that we call, and we like to use like methods like for each or any utility method, like something like
Map,
any wrapper provides
filters,
map filters, or like the Kotlin extension methods, etc. There's a heavy performance hit on the bytecode level.
So you have an instruction format which is being mapped by to a high level language to an instruction format.
Yeah, the bytecode level instructions.
What happens in this map, filter, for each versions, you have like add-on lines in that instruction format. So that adds the overhead to the bottom layers. The instruction format increases in that case. So it will be like going to take time in that case.
Yeah. For example, one example that I could think of right now is that the difference was between a normal for loop and a for each loop. A normal for loop would actually use like 4 registers and some like 4 to 8 bytecode instructions, whereas our normal for each loop would use 8 registers and like 8 to 16 bytecode instructions, depending on the like logic. If you have like any if condition.
So if you have quite a bigger for
so
iteration process, then a for loop wins the race because there is
correct.
less number of instructions.
Yes. So in the bytecode level, it's faster. It's like it's half the amount which a for each loop would take.
So every good comes with its bad.
Yeah. So like don't I would suggest like use all these extension methods and the utility methods like after you are aware of like what it is
what is
doing.
the cost?
What's the cost basically?
What is the implied cost?
Correct.
To summarize, I guess we learned a hell of a lot today.
Yeah,
From the process, from the moment the phone starts, and there's a loader, okay, we are loading the apps, and there's a entire, process which runs behind that the user doesn't see for optimization of the app just in time, ahead of the time. Then even when you're actually running the app, and when you're using multidexing, I guess we learned a hell of a lot today.
And from a high level language to the bytecode generation.
So you have to think about that also.
Yeah. So I think this is very important, not for the user point of view, but from a developer's point of view, so that we could actually make our apps more better, more gruesome, more crispy, more performance efficient.
And with Dexter, the library that they are working on, I guess the quote is true that with necessity comes the invention.
Guys.
Because all of our applications are definitely going to scale to a lot of like to big size, right? So Dexter will prove like a very good.
They have a very good vision. They have a very good vision, and they have very far-stretched vision of optimizing to the level of methods also.
Yeah.
And if they work really well, and that they're doing also, so this can be real handy for all the developers to come in and throughout the globe. Yes. Yeah. So that was a very nice session.
Yeah. So thank you for your time. I would I would like the time to say use Dexter. Give us more like improvisations of features. Like if you would think of something and like raise PRs. Any PRs are welcome.
Yeah, sure. Nice. So I wish you will do. Thanks again. And that will be all. I guess. Cheers.
Cheers.